We started by switching from SE80 into Eclipse to allow us to see more code and show the Project Explorer at the left side. In last video we tested the scalar multiplication and normalization of vectors, and today we shall add the vector addition and subtraction. Notice that we cannot yet perform cross products on vectors when dimensions are higher than 3. For that, we will need the support of the ZCL matrix class, which is now added to the project. We also added a static to string method to display the content of the vector in addition to the instance to string method. Back to the test function module, we added a string table to return the collected operations using a macro called log. Vector addition is now being tested. For that, we add v2 to v1, changing the vector v1 to be v1 plus v2. Look closely and check that a utility class called ZCL Utilities is now used to encapsulate reusable code. Since the normalization method freed the original v1 and replace it with another, the utility method called heap address shows the actual memory address of the heap of the ABAP application server. To return v1 back to its original values, we called the subtraction method to subtract v2 from v1. As mentioned, the cross product is awaiting the ZCL matrix support. To achieve that, we create a new class called ZCL matrix and wrote the constructor which create n time m matrix of any type and initialize it to whatever is the default value for the given type. To adhere with the model, we added the toString method as an instance method and called it to retrieve the value of each XY pair. Being shown are the stub methods of class ZCL matrix awaiting implementation. With the exception of the constructor and toString methods, all others are empty. The matrix construction is based on dynamically creating a real ABAP type from the type kind being requested, and using this newly created ABAP type reference to create a dynamic table with one column of that type. The utilities class execute these operations since we are going to reuse them in the ZCL vector that, at the moment, only makes vectors of type float. Using the utilities class, we propagate the single column into a series of columns matching the requested matrix of n columns. At last, we inserted as many lines to the underlying container to achieve the m rows. The toString method shows that each pair RC of matrix M1 defined as n by m is now initialized with default values for the specified type. Inspecting the contents of the string table, we see v1's original values, the effects of the scalar multiplication by 0.5, and its original pointer in the ABAP heap memory. Before the effect of normalizing v1, the log shows the heap address as 035. After normalization, it is now 038, and the previous instance of v1 was freed up. Next, v2 is being shown, followed by the address of v1, which assures we are going to add v2 into v1's normalized contents. The results of v1 plus v2 is shown. We repeat the heap address method to show that v1 is still the same vector as before the addition operation took place. Repeating the logic above, we now subtract v2 from v1, returning v1 to the values it had after being normalized. At last, we show the content of matrix M1 defined as a 10 by 10 matrix of type float, initialized with zeros. The strange pound sign is nothing else but the new line operator, which is interpreted as such. Our next video will change the implementation of ZCL vector to be dynamically based on past type kinds, as well as completing the missing code for the remainder of the vector class.